Good morning, guys. So yesterday we did simple interest. Today I'm going to do compound interest with you. So compound interest is the amount of interest you can earn on your investment and any previously earned interest. So with simple interest, you only ever earned the interest on your original investment. With compound interest, you basically take the interest that you've earned, add it to the principal, and then you're kind of like starting over every time. So you're always adding the interest in and then recalculating. In this case, interest is earned on the original investment, added to the original investment, and then added, you can earn even more money. So let's take a look at the formula. The formula is here: A equals P, 1 plus I to the n. So it does have an exponent in it. A is our future amount, so it's basically the amount that's going to be in the account at the end of the investment, or however long you're calculating it for. I is your interest rate. We're going to put that into decimal form. So it is in decimal form, just like in simple interest. Divided by the compounding periods. We're going to talk about that just in a little bit, but make sure that you do this, and I'm going to show you in the example that we need to do this as well. P is your principal investment, so how much you actually put in, similar to simple interest. And N is your total number of compounds. Now, usually this is your years times the compounding periods in a year. And I'm going to show you that in the example as well. So we've got the formula. There's one other thing that we kind of need to go over. So I just quickly want to talk about compounding periods. So compounding periods is how often your interest is calculated and added on. So it depends on the investment as to what you're going to do with it. So I've done a nice little chart here that you can kind of remember how often it is, and you're only going to see these ones. Rarely do I use any other ones because these are the most common, especially monthly. That's probably the most common if you go to the banks. So annually is once a year, which means we're going to divide by 1 or multiply by 1 when we look at our interest and our total number of compounds. Semi-annually, twice a year. So our magic number is like 2. Monthly, 12 times a year because there's 12 months. And quarterly is 4 times a year. Using these two things in mind, we're going to do the example question. I'm going to show you how everything works. Okay, so let's say that you invest $2,000 into an account that earns 6% compounded monthly. How much will the investment be worth in 6 years? Okay, I like to underline, again, same thing, underline all the important things that I need to keep track of. Now, because we're compounded monthly, I like to go back to the chart that's up above. And if we think about it as our magic number, because it's monthly, our magic number is 12. So we are going to use that 12 when we do the solution. So as we did in the previous lesson, I like to write things down. P is our principal, so I write down 2,000. I is our interest rate divided by our magic number, our compounding periods. So in this case, our interest rate is 6%. I'm going to put that in decimal form, just like I did yesterday. But in this case, we're going to divide it by 12 because it's compounded monthly. So I'm going to calculate that first. And I get 0.005. So this is the number we're going to use when we do our formula. N is our years times our compounding periods. So in this case, we're going to invest it for 6 years. And it's compounded monthly, so we'll multiply. So 6 times 12 is 72. All right, once we have those three values, please, please, please don't forget to calculate I and calculate N, because that is where lots of the mistakes may happen when we do these types of questions. So we'll use our formula, 1 plus I to the N, and we'll sub in our values. P is 2,000. 1 plus 0.005 to the exponent of 72. Again, don't forget that we need to follow BEDMAS, so we'll do our brackets first. 2,000. 1 plus 0.005 is 1.005 to the 72. We'll do our exponent next. So when I get it, I get 1.432044278. Now, a lot of people get to this and they say, Jen, do I really have to write all the digits down? The best thing to do is, yes, write all the digits down. It's not good to round in the middle of our formula, because then we might lose out on some money at the end by rounding. So always keep them. I know it's a pain to write them all in, but trust me, it's better for you. And then we'll calculate it. We'll multiply the two, and I get 2,864.08857. Now, because we're dealing with money, you are allowed to round at the end, not before, at the end. So I will round it to $2,864.09. Okay, this is how the bank does it. They keep all the digits until the very end. So that's the way we're going to do it. Okay. If I was to ask you how much interest did you earn? How much interest was earned? You can easily figure that out by doing the 2,864.09 minus what we started with, which was 2,000. And you see that over those 6 years, you earned $864.09. Okay, so moving to the other page, one more example just so that you can see it again. Again, I'm going to highlight the things that are important. So you invest $5,000 into an account that earns 4.2% compounded quarterly this time. How much will your investment be worth in 5 years? So again, I think quarterly is 4 times a year. So that's our magic number. That's the one we're going to divide and multiply when we calculate I and N. So again, let's make our little list. P is our investment, which was $5,000. I is our interest rate, which is 4.2%. I'm going to put that into decimal form. And I'm going to divide. Sorry about that, guys. Divide by 4, which is our magic number. So 0.042 divided by 4, 0.0105. And then N, 5 years times 4 times a year is 20 times total. And then again, we're going to use our formula. 1 plus I to the N. We'll sub in our values. 5,000 times 1 plus 0.0105 to the exponent of 20. Again, make sure you follow BEDMAS. So I'll do all the steps for you so you can see them. I'm going to add it. Then I'm going to do our exponent, 1.0105 to the exponent of 20. And I'm going to keep all the decimals. So I get 1.232328116. And then I'll multiply by 5,000. 6161.640578. And round it so that we get a dollar amount, $6,161.64. And that is how simple or compound interest works. If you have any questions, please ask me. This tends to be the one little tiny lesson that I don't know why it throws people off. I'll try and put some extra videos up there so you can kind of see how it works. But please make sure you do the questions. And if you're having trouble with it, ask me. Okay? Thanks, guys. Bye.